deriving the cosine rule. Similarly to the sine rule, we're going to start looking at the cosine rule with a triangle ABC, pretty arbitrarily drawn, and I'm going to drop a perpendicular to the side AC down from B, giving me two right-angled triangles. If that full distance across there is B, we'll label this, of course, as the height, and we'll just put in an expression for this being x, and so this, don't add any more pronumerals if you don't need to. If that's x, then, oops, I didn't put my point in. This point here is P. So this side AP is B, take away x. So we have two right-angled triangles, and again we're going to use, in this case, Pythagoras and the trig ratios to derive the cosine rule. So we start with triangle BCP, this one here. You don't really need to redraw it, but I'm just trying to keep things clear. I've got H, A, and X. And to keep things simple, I'm just going to choose the relationship that we want. If I use Pythagoras to write a relationship between these sides, I would get a squared equals x squared plus h squared. Take the other triangle. Sorry, I'll just zoom out a little for us there. Take the other triangle, ABP. And this is B minus X. Now, if we again took the hypotenuse there, c squared equals h squared plus b minus x squared. If we expand that out, I might just expand out b minus x squared somewhere else. B times b is b squared, b times negative x is minus bx, negative x times b is minus bx, negative x times negative x is plus x squared. Simplify, I've got b squared minus 2bx plus x squared. So c squared equals h squared plus b squared minus 2bx plus x squared. Now, if we just looked at h squared, that would be a squared minus x squared. And as you can see, I've got h squared here, and I've got h squared here. So I can substitute this version of h squared into here and get c squared equals, and I'll keep that in pink just so you see what we're doing, a squared minus x squared, that's my h squared, plus b squared minus 2bx plus x squared. Simplify this, I've got minus x squared plus x squared. So I'll come down to c squared equals a squared plus b squared minus, oh, sorry, I lost a 2 somewhere, minus 2bx. So we've got that far. Going back to this triangle, and finding cos of C. Cos theta is adjacent over hypotenuse. Cos of C is x over h. So x is h. What did I just do? It's not h. That's a. That is the hypotenuse. Good grief. H, let me just get there. So, A cos C equals x. Am I correct there? Yes. Sorry about that. This is why you should always label your sides. It doesn't help that we've got A and H, and that's the hypotenuse and that's the adjacent. But no excuse. So, I've just got A cos C, and that equals x. So I'm going to substitute A cos C in where I've got that x. C squared equals A squared plus B squared minus 2B A cos C. And as we should write our pronumerals in alphabetical order, C squared equals A squared plus B squared minus 2AB cos C. And that is your cosine rule. As with the sine rule, we could quite easily put our divider down here or down here and get the relationship of the other sides, and they would all work out in that same relationship. Remembering from your exact values, if angle C is, and if we have a look over here, if angle C is 90 degrees, so if in fact this is a right angled triangle, you'll remember from your exact values that cos of 90 degrees is 0. And minus 2 times A times B times 0 is all 0. So when we have a 90 degree triangle, all of this equals 0 and disappears, and we're left with Pythagoras.